graphs, and then you guys can try 4 problems for homework that I have here at the end, and try your Math Excel assignment. When we get back to school, we'll spend a few minutes going over these 4 problems to help you out for our test on Friday. Okay, first one I want to try is 2 secant of x. Now, a 2 spreads it out like it did for sine and cosine and tangent and cotangent. But the kind of weird thing about this is, how does it spread it out when we have this bunch of parabolas? Well, here are our normal x values for secant. Let's go ahead and put on our asymptotes. Those don't change. Negative pi over 2, pi over 2, and 3 pi over 2. So we still have those. So I can move that over. All right. Now, it's going to spread out. Now, usually we have a point here at 1 and a parabola that's pointing up. That's what we usually have for secant. Now, what this 2 right here is going to do, this 2 is actually going to move this up. Instead of being at 1, it's going to move our parabola up to 2. So then I'm going to have a point right here. That's what it's going to do. Okay. Now, what about the one that's right here? That's where it is normally. Instead of being at -1, that 2 is going to stretch it out. Okay, and put it down here. Now, the reason it does the stretch out is because this is very similar to a cosine graph. If you had cosine to cosine of x, wouldn't that start here, go here, 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 and continue on over here? As you can see, for a cosine graph to cosine of x, how it's related to secant of x, the amplitude actually moves it up. Okay? Now, so that's how that behaves. Secant and cosecant are the same in that manner. The domain of this problem still is the same, pi over 2n, where n is odd. My range definitely changes. Now I'm going to go from -infinity to -2, union 2 to infinity, period, still pi, 2 pi. All right, let's try another example. Let's see what else I got in here for you. Okay. Okay, let's try this one. This is a good secant problem. All right, now what's going to happen here? Is this going to be the same as all the others from before? When we've done this before, we've had this triple table. Let's go ahead and put in our normal x values for secant, which you guys are going to have to memorize. Negative pi over 2, 0, pi over 2, pi, and 3 pi over 2. Now, what do you guys think I'm going to have to multiply all these by? That's right, 1/3. So we're going to multiply all these by 1/3. Now I'm going to get my new x values. Multiply across, negative pi over 6, 0, pi over 6, pi over 3, and actually that would be 3 pi over 6, which would reduce to pi over 2. Okay, so I'm going to put on my new x values, negative pi over 6, 0 is still on there, pi over 6, pi over 3, pi over 2. Go ahead and put on my asymptotes. Still at pi right here. It's a little crooked. Right here and right here. See if I can make a few adjustments here to make this look good. And then we'll go for our graph. This was secant, right? Secant, right? So it'll go like this. First parabola up, second problem, the parabola pointing down with my vertex. Now, the domain of this one, okay? Let's think about what that would be. Now, our normal domain is pi over 2n, where n is odd. Now, that's what it used to be. To get my new domain, okay, it will be, I'll take that pi over 2, and I will also multiply that by 1/3 to get my new domain. So I'm going to take that part of the problem here. I'm just working on this right here. I'm going to multiply it by 1/3, just like I did with the x values. And then my domain will be pi over 6, where n, pi over 6n, where n is odd. Okay. My range, how's that go again? Negative infinity to -1. Okay. Union 1 to infinity. I'm supposed to have parentheses. Oh, actually, those are brackets right there. Those are brackets. Now my period. My period for this one is like the shortcut for period for sine and cosine. I'm going to take 2 pi and I am going to divide that by the number in front of x. That's going to go right here. Okay? So when I divide that, I'm going to divide that by 3, and that'll give me the period of this function. All right, let me try one more graph for you. Let's do a cosecant one. Okay. All right, so we're going to have our triple x values. Let me do that. A triple table. I'm going to multiply all of these by the reciprocal of this number, which is actually 2. That's weird. Multiply all these by 2. So I would wind up with my new x, 0, pi, 2 pi, 3 pi, and 4 pi. Okay. And I'll go ahead and put in the asymptotes. Right here, this is cosecant, right? Here and here. Okay, not bad. And I'll put my parabolas. Okay, the first one, this will be up to 1. Okay. And then here at -1 down here. Okay. One more thing I'd like to mention before we close this out. Okay. If I had the problem, let me do this in black, negative cosecant of a half x, 1/2 x. What would that negative do? It would actually take this, that's right here, and flip it to like this. So it would go down first and then up second. That's what a negative does to these problems, okay, if it was that. All right, guys. Now, for homework, I want you to try these 4 problems and do your Math Excel assignment on secant and cosecant. Thanks for listening, guys. Have a good snow day, and I will see you next time. Thanks.